I'm very pleased to have my brother here, Phil, who's based in Stockholm in Sweden, and his job is in bioinformatics. So he spends a lot of time manipulating data and making it beautiful and such like. And when we did this workshop in 2016 in Cambridge, Phil very kindly came and talked to the students there. So we thought it would be a good idea to do something similar now. So with no further ado, I'll hand over to you, Phil.
Thank you. Yeah, it's nice to be here. This is kind of a nice, fun little sidestep out of my normal day-to-day to come and talk about this kind of stuff now. So it's nice to be here. Going to have an hour and a bit with you guys this morning talking about visual aids, what that means, and basically sort of how to use visual aids in the best way possible to get your message across when you're presenting your science or just doing anything really. I put in a couple of intro slides as well. So just as a quick overview of what I'm going to talk about, I'll kick off with a general introduction as to kind of my definitions and what it is I'm talking about, what I mean. We'll go over some just basic general design stuff for which can apply to absolutely anything. We'll go into more specifically some stuff about data visualization, which is relevant to everyone working in science, especially. We'll touch on color, because color is a really important topic and deserves its own section. And then at the end, I've just got a couple of slides about some of the tools that I use on a regular basis, especially to make PowerPoint slides and things like that. So that's roughly the overview. I think the bulk of the time is going to be spent on data visualization in the middle. So who am I? Just so you have some context here. I started off in biology as a molecular biologist. So I did my PhD in the lab, working with genomics, epigenetics specifically. I also had a side hustle since I was a teenager to do web design. So I had a little kind of self-employed company for a few years. I did a bunch of websites. So I've always kind of had a side interest in design and computers, coding, and also kind of making websites look pretty. Towards the end of my PhD, I realized that some of this experience kind of overlapped and stepped into this new role of what we term in bioinformatician, which just basically means data analysis for biology. So I spent most of my days getting DNA sequencing data and manipulating that and trying to turn it into something useful. So I love that. It's really a fascinating job. And what I got more into as time went on was building tools to allow other people to work with bioinformatics. So these days I would class myself less as a bioinformatician and more as a software developer, and also a kind of community builder. I've over the years built up some quite large scientific communities of several thousands of people collaborating on tools. So I also spend a significant chunk of my time curating and managing that now. So that's my sort of slightly winding, strange career path to get me to where I am today, and also gives you some insight as to why I'm particularly interested in data visualization, because it's really sort of been a red line that's sort of a thread that's followed all the way through my career. I'm from the UK originally, so spent many years in Cambridge. Originally, much of this material I first did when I was doing my first postdoc in the University of Cambridge at the Babraham Institute. So hats off to them. They still run this course, and it's changed quite a bit since then. So if this was really interesting and you have a thirst for more, go and check out the Babraham Institute Bioinformatics team, and they have all of their training materials up online, and their data visualization course is great. And you might even notice a slide or two which looks similar. I don't know how much it's changed over the years. 9 years ago, I moved to Sweden, worked at the National Genomics Infrastructure doing DNA sequencing, data analysis systems, employed at Stockholm University. There's also a collaboration between other Swedish places. So I think we're going to, next up after me, you're going to hear a little bit about Hans Rosling, who's from Karolinska, which is where I was based. So he's a personal hero of mine. And then for the last year, I've been working at a company. So I left academia into this startup company called Secura Labs to focus on 2 software projects, which I've been heavily involved with, which are both open source scientific software. And this is usually what I spend my days talking about. So if you're at all interested in data analysis workflows, so sticking together different steps of data analysis, check out Nextflow. I've been trying to get Chris to use it for years, so maybe you guys will be the ones to break out. And also a data visualization tool actually called Multi-QC, which can build quality control reports for basically any type of data. Both of these have come from genomics, but they're agnostic. They would work with anything. Onto the content. What is a visual aid? What are we talking about here? I'm talking in the very broadest sense. So the three sort of main categories I think are most relevant for the people in this room are figures. When you're writing a manuscript, a paper, and every time you put a figure together, that's a visual aid which helps to tell the story of what you're describing in the text. Talk slides are another obvious one. So what you're looking at now, you can give a talk without slides, and some of the best presenters do. If you think of TED Talks and things, you often have people just stood at the front without really anything. But obviously, it's very common to have a PowerPoint presentation, and this is a visual aid to help you give your presentation. And posters is another good one. Again, sort of displaying your scientific data in a visual format to help you have discussions with people at a conference. So why do we need visual aids? Basically, we're really good as humans to try and think about images. How many people read all the bullet points on the last slide? Okay, can anyone tell me what the content of the last slide was about? Can anyone tell me what the picture was of?
Sunglasses on.
Yeah, great. What color were the sunglasses?
Yellow.
What kind of cat was it?
A long-haired Persian type cat.
Was there anything special about it? That's a real difficult trick.
I was looking down towards the left-hand corner of the slide.
Very good. Yeah. Yeah, it had funky flat ears. I'm biased. I had a cat of the same type, so you go. It's got folded ears. It's a Scottish fold. My point here is that all of your brains took in a lot of information about that picture very, very quickly, whereas the text said stuff that was meaningful. It was talking about how your head is good at just breaking apart images, but we are as humans tuned to work with visual imagery. We get much more information from a visual image than we do from text, and with much less effort. So, and the other thing about it, so that's the sort of the main reason, really. Text is good for heavy, dense content, but visual aids are much more effective at getting a message across and getting sort of data across. So we use visual aids to help us to explain something to someone else. That's sort of the main reason. It helps us to get a point across. It helps us to describe what we're talking about. Visual aids also help to make your point much more memorable. You almost certainly won't remember most of what I talk about, but you might remember a general feeling for it, and you might remember the cat. So visual parts tend to be much more memorable, and they just make things more interesting. I'm sure many of you have been in talks where the presenter has slides of text, and even if the content of the talk is very interesting, you might struggle to fight off that feeling of kind of feeling a heavy eyelids. Whereas if you have a presentation which is very visual, it tends to be a bit more interesting, and that's kind of better. All these things, of course, are interlinked. So, okay, visual aids are great. How do you go about building a good visual aid? Probably the most important thing is to know your audience. Think about who you're talking to. You cannot build an effective visual aid without thinking about this ahead of time. You have to empathize with the person who's going to be seeing the visual aid and know what kind of background they're coming from. It's really important to keep it as simple as possible. The simpler a visual aid is, the more effective it is. And really sort of think about it before you start working on any visual aid. So plan what it's going to be like, structure it. Obviously, how this looks depends on what kind of visual aid we're talking about, but the idea is the same. You need to think about it a bit rather than just start dumping onto a slide or whatever. So when I say about keeping it simple, we're kind of thinking about this idea of sort of where you might have, say, for a graph, you might have a lot of data. You need to really sort of try and distill all that down to a core concept. The aim is not to show all of the data necessarily. The aim is to get your point across, your core concept across. So you need to sort of think about what it is which is most important. A couple of quick examples. Of course, I can start off by being very kind of meta. The talk slides, these talk slides you're looking at right now are a visual aid. This slide deck is helping me to teach you guys about visual aids. Told you it was meta. Within the slide deck, the icons are visual aids. Instead of long rows of text, I'm making a very heavy use of these little icons, which help to just give an aid to what the text says. And you might notice I've got a kind of a green number 1 up in the header. That's a visual aid to give you some indication of how far through the talk we are. So, I mean, you can kind of break this down to ad infinitum, but like all of these things are different examples of where I've consciously tried to use a visual aid to help me get my points across. Another example from last time I gave this, graphical abstracts from scientific papers are a great example of a visual aid. With basically no text here, can anyone tell me what this paper is going to be about? Or what technique it uses, at least?
Can you hear people? People have been saying AFM, atomic force.
No, sorry, I can't hear that. You have to shout at me. Yeah, AFM, well done. There you go. So again, very quickly, right, that's quite a dense paper title. But from the image, you immediately know roughly what this is going to be talking about. And you guys, probably more than me, will have much more insight about what this is trying to tell you. So this visual aid of a graphical abstract gets across the point of the paper much more effectively than a block of text. Okay, now one from my work, this is a table of data that I put, this is old now, but it's a table of data that I put into a talk. And I gave a talk and I thought afterwards that was hopeless. No one got my take-home messages. I had to really talk through all these numbers. So we can kind of go through column by column here. I've got a sample ID number on the left. That's really important for me and our internal systems. But the people I was presenting to didn't care what project number it was and all that kind of stuff. So we can simplify that. The library prep, we do need all of those because they're different. Each one tells you a difference. But what's really interesting there is not individual library prep names, but the groupings. And then after that, we've got 2 columns of numbers, and we're just really bad at doing numbers. The starting amount, the number is necessary. People need to know what the number is, but the sequenced reads, that actual absolute number doesn't really matter at all. What's important is a relative number. And you can sort of get a feel if you look at it that some are kind of varying more than others, but it's very difficult to give an accurate comparison. So I went back and I thought about how I could handle this and turn that table into this. Sample ID is now just a simple number. That's plenty enough. Library prep is still there, but we've background colored into the groups so you can see at a glance what the different groups are. Starting amount I've made into a bar plot, but I've kept the labels. So we still have the numbers easy to read, but you can very quickly see the relative proportions. And sequence reads, I've got rid of the numbers at all completely because they were distracting. And it's just a bar plot now with an axis. So this is kind of an example about taking a visual aid, which was a really bad visual aid, and trying to turn it into something which is much easier for an audience to interpret. If you have any questions, shout, by the way. The more questions, the more interactive it is, the more fun this is. Okay, so that's what I'm talking about when I'm talking about visual aids, right? Now, many of you, I'm sure, will be used to seeing PowerPoint presentations like this. Maybe some of you might even have seen presentations that look like this. Hopefully not, but I know I have. Right. The point I'm trying to make here is that visual design is important, right? Think about those first impressions you make when you stand up in front of an audience, maybe at a conference where no one knows you. Now, the first thing they take home about you is the first slide or first 3 slides. And immediately they've got a first impression of you and they are going to decide about how much attention they want to pay to your talk. And things like that. Right? This design is really important. If you can make your slides simple and easy and attractive, then people will sit up and take notice. And you will do a better job of getting across your science, which is what you want to do. So you'll achieve your objectives. And the other take home I want to try and imbue with you today is that visual design does not need to be difficult. You need to be conscious about it. You do need to spend a bit of time dedicated to it. You can't just ignore it, but it doesn't need to be difficult. It is easy. And there's 3 main things we're going to think about, especially when thinking about talk slides: fonts, colors, and layout. So a couple of simple guidelines for using fonts effectively. Everyone know what I mean by fonts, yeah? Typography, so the style of the text, the way it looks. Really good starting point, which is just general advice I give to everyone who will listen, is to avoid the defaults, right? If you're using Microsoft PowerPoint, just don't use Calibri. Just try and pick any other font. It doesn't really matter what you pick, but if you pick something other than a Microsoft Office default, that's immediately you're off to a good start. People won't notice you've done it, but it gives a slight subconscious nudge that you are thinking a little bit about your slides and you have actually done something here, right? It's super easy to do. All you do is you go to Google Fonts, which is a website. I've got the link at the end, and you just pick a font you like. That's all it is. You install it, you download it, install it, and you use it in all your presentations, and you never use Calibri again. Great, you're off to a good start. Next, remember about the concept of font weights. So what I mean by font weights is making something bold or regular, but it's more than just those two. A good font will have 3 to 6 to even 9 different font weights, which you can choose from, all the way from bold or heavy down to very thin or hairline. Now, this is a really good way to, without switching through lots and lots of different types of fonts, give differentiation between different texts, and also specifically give hierarchy and weighting to a type of information you're giving. So important headers can be bold. Minor things which are not very important can be kind of thinner. So use font weights. Once you get into the habit of it, it's easy. It's just remembering that this is a concept which exists. Break up your content. Pick a font and stick to it. Try not to skip around between different fonts. If you have anyone like me sat in your audience, it will really make them wince if you switch between fonts on different slides. Again, most people won't notice, but it's kind of a subconscious tick. So try and be consistent, and try and consider also what the font says about the content. And this is a recurring theme I'm going to talk about, is that everything has kind of a subconscious link and implies different things. What do I mean? Road signs. Everyone is used to seeing road signs, right? Have you ever seen a road sign that looks like this? I can guarantee you haven't. This is using a serif font. So there's different classes of fonts. And serif fonts have a typical type of things that are used for, and road signs is not one of them, right? This is what
could you just say what a serif font is? So
yeah, okay, next slide.
Oh, sorry. Okay.
I rearranged this. Yeah. So this is what your road sign looks like. And again, I've changed fonts, and with that have got like a lot of kind of implied knowledge. And even there's a specific font, certainly in the UK, which is used for all road signs. So consistency and sort of implied use. Here we go. So I probably should have put this first. Serif font means it's got all the little taggy, dangly bits. So at the bottom of the letter I, it flattens out into a line. At the ends of the S and everything, it just means that you have all those bits. Whereas a sans serif means you don't have the serifs. So that's all it means. It's the two main classes of any font. And then you can have this kind of third class, which I've termed decorative fonts. So when do you use these different types of fonts? If you're writing a block of text, you can use either serif or sans serif. I used to say use serif for block text. If you're doing a manuscript, right, use Times New Roman. Or if you look at reading a paper online, it always used to be in serif text. This is changing though, and more online manuscripts and stuff are starting to use sans serif fonts. So I think either of those is now fine. But certainly this is where serif shines. Serif fonts tend to be easier to read in small font sizes when there's a lot of text. There's a greater differentiation between the different letters in the words, which makes it easier for you to read. They also tend to look more formal. If you're doing a figure, it should basically always be sans serif. So even if you're doing a manuscript and all of your body text is with a serif font, nearly always the figure legend will be sans serif. And if you're doing a presentation, I would recommend that you just always use sans serif. Sans serif fonts tend to look better in larger font sizes and tend to look better in digital visual displays. Now, you might notice I've not used decorative anywhere here. I could have a fourth category that says children's birthday invitations, or I don't know, music posters, things like that. But obviously, in your day-to-day work, you should basically never be using a decorative font. Let's have an example. Can anyone recognize this slide? Anyone seen this slide before? Go on, shout. What talk is this from?
I don't know.
A very famous talk. It was a talk where they announced the discovery of the Higgs boson. Global news, right? This is massive, massive news. And most of the media coverage was about the fact that she displayed it in Comic Sans, which is sort of heartbreaking. So this is quite old now. This is 2012. So maybe some of you in the audience were not really thinking about Higgs bosons and stuff back then. But if you dig it out, you can still find the media coverage. I thought this was kind of hilarious because I have it's a bit of a running joke about how much I dislike Comic Sans. But the point is the same, right? It's very obvious to you when you look at this slide here that this is not giving a good first impression. When she stood up and gave a live talk in front of a truly global audience of probably certainly thousands, if not millions of people watching this live, this much awaited, anticipated announcement that they've been having press releases and everything. And then this is the first slide with all this Comic Sans everywhere. This is not an appropriate font for giving data of this gravitas. I mean, it's fine, you can read it, the information is there, but the use of a font and the association is poor, and certainly everyone outside of science thought that it was hilarious. It's not the only example. You can find many more examples of inappropriate use specifically of Comic Sans. If you Google for it, you'll find websites dedicated specifically to being angry about the use of Comic Sans. So if in doubt, never use Comic Sans. Simple. You can't go too far wrong. Okay, any questions on fonts?
Yeah, there's a cultural difference because French people love Comic Sans. I've seen loads of talks here in Comic Sans.
Well, if ever you give a talk to someone in the audience who's not French, you shouldn't be using Comic Sans. Yeah, right, I need to move on a bit. I'm going a bit slow. Color. I'm going to cop out a lot here because color is a massive topic and I'm basically not going to talk about it. Two things that I want to draw your attention to. Again, implicit association of color, right? Red, yellow, green, traffic lights. If you do something as red, then it's going to be bad. Green is good. Just think about that, especially with plots, color schemes. There is an association with everything you do. So if you're plotting something that goes from a number which is bad to good, then red to green is good because or red, yellow, green is good because the person doing it doesn't have to look at the number to sort of make that association. So you can use color to great effect by using this inbuilt association. And then this kind of slide below is about making color schemes. There's all very different formal ways to make sure that colors go well together. And this is a whole color theory is like a whole field. Don't worry about it too much unless you're super interested, but just remember that the colors you pick are important. And again, that subconscious association. If you're interested, go and check out Google Material. This slide, probably without looking at anything it says, you'll know it's Google. And that's because Google uses a very strong branding theme, and they have a lot of really nice information about how and why they make the decisions they do, and a lot of stuff about design theory and also color palettes that you can use and things. So it's a good place to start if in doubt. Layout. Just touch on this again. Layout is also important, and again, impressions, right? I can't leave this slide up, it does my head in. Need to think about spacing. Everything on your slide, everything in your graph needs to have adequate spacing around it. It needs space to breathe. A little bit of white space just allows things. It never let something sit right up against the edge of a window or a box. Make sure that everything is aligned in your slide and make sure it's appropriate sizing, especially make sure that text is not too small and figures are not too small. If in doubt, on a PowerPoint slide deck, split things out into multiple slides. Having lots of slides is not a bad thing. You can move through the content at the same speed, but having it bigger will make it easier for people to read. And instead of squinting at the slides, they'll be listening to what you're saying. For alignment, these set of tools are your friend. If you're not already very aware of them, you should be. Never let a PowerPoint slide go onto a screen without having. Oh, have you frozen? I think I've lost you. Oh, we're back. Did you lose me for a second?
Yeah, sorry, we lost about 3 seconds there.
Yeah, I was just saying, don't make sure that basically you use these tools on everything on all your PowerPoint slides. Make sure everything is aligned, middle, center, etc. Cool. Onwards, data. Right, I'm specifically talking about graphs really here. Same concepts. Which type of graph, not which, there's a subtlety in the language here. You should be thinking when you start off, not which graph can I use to show all my data. You should be thinking, which graph can I use to get my point across? What is the point I'm trying to make? What is my story? Which graph helps me make that story? That is a key difference and is a mindset that you need to be in every time you sit down to make a graph to show someone. An extension of that is which of my data are really necessary. I have all this data, which bits of that do I need to get my point across? The less data you show, the more effective your graph will be, effectively, within reason, of course. Like if you go too far, then people are gonna not trust it, or you might miss something that's important. So find that balance. What can I remove from this graph without it losing anything? And then which type of graph? Graphs can be roughly split into sort of 4 different groups. Graphs can show relationships between different things, composition of groups. They can be comparing different things, and they can show a distribution. What does this plot show out of those 4 categories? Shout.
Relationship. No, sorry. I'll shut up.
Come on, somebody say, join in. Who thinks it's distribution? Who thinks it's composition?
What do you mean by composition?
What thinks something is made of?
Okay.
Who thinks it's comparison? Who thinks it's relationship? Who hasn't voted yet?
Yeah, I was going to say who hasn't voted.
You think it's a picture of 2 skyscrapers in Manhattan?
This is a basic comparison.
Yeah, most people voted comparison.
Yeah, we've got 2 numbers and we're just trying to compare them. Say one is bigger than the other. Simple. You know how this works. What's this one? I can't really hear, Chris. You're gonna have to tell me.
Distribution. Most money is on distribution here.
Yeah, it's a distribution. Well done. It's a comparison as well, right? We can compare the median here, these box plots. We can compare the maximum, but primarily the main distinguishing feature about this graph is it's showing us a distribution of the data, how much it varies.
Okay, most people are voting relationship here.
You've got it now.
Well.
Yeah, imagine that the x-axis here could be a time series or something like that. We've got one sample which has got multiple data points, and we're looking at the relationship between those data points across some kind of axis. There's only one left now, so hopefully you'll get these. Composition. Right, so the scatter plot is it, right? We're looking at, our brains are telling us how these points group together. So composition is saying, right, we're finding patterns here in this graph, and that's a composition. Make sense?
Yeah, lots of nodding heads.
Good. Example from my first postdoc, I think this is. This was a eureka moment. I've been doing some analysis of my genomics data and we were putting together a figure for a paper. And I presented it in a group meeting and I showed this. And I had to talk for a long time before people got on board with why I was excited. What I went to, I'm going to skip straight to it to the end now. The final iteration that went into the paper was this. So what's different here? The problems we had with the first plot are those distributions are not relevant. Right, I put them in, it's useful for me to know, it means I trusted the data and stuff, but when I'm trying to make my point, the distributions don't matter, that data doesn't need to be there. The thing I really cared about here was the median value, just the average. So first thing I did was I cut all of that superfluous data out and kept just the piece of information which was most important. The other thing is that because that's a panel of 5 different plots which have separate axes. In fact, even the axes have different ranges. Anyone reading has to firstly flick all their eyes pairwise between all these plots to compare, and secondly, they have to actually read the numbers and then normalize those axes in their heads, which is really difficult to do. So at least all the axes should be the same, but it's much better actually to try and put all of the data onto a single graph, onto a single panel, because then we can compare. And that's what I wanted people to be doing here, is I had different subclasses of data and I wanted them to be comparing between the different groups. So by cutting down the data and putting it all on top of each other, now you can see at a glance that clearly the blues are behaving differently within L2 and L1. But looking at the original plot, it was very difficult to tell. Right. This is thinking about all those things I've just been talking about, right? Cutting down on data, thinking about what the point is that I'm trying to make, and thinking about the type of graph which is relevant. Here, these are relationships for each of those series because it's the same sample across 5 different conditions.
Just a question, would you chuck the left-hand plots into supplementary material just in case, or would you just dump them?
Could do. I can't, it's too many years ago for me to remember what I actually did. Probably just dump them, honestly. Like keep them in your computer somewhere. No, best of all, have a GitHub repository of all your code where you generate these plots and keep it there. So if anyone is interested, they can go back to your source analysis and see the data. But I don't think it needs to go in the paper because it doesn't tell you anything. Come back next year and I'll give you a talk about reproducible research and GitHub. Okay, so types of graphs, and we've talked about the different classes, but obviously there's many different plots you can use to make a comparison. What are good types of plots to use? What are bad? Your brain is really good at fast and accurate judgment of quantitative data if that data is presented using either length or slope. The bar graph we looked at used the length of the bars, and you're able to look at those and your brain is really, really good at figuring out which one is longer. The line graph I just showed you on the last slide, those lines were at different slopes. And again, your brain was able to compare the slopes of those lines very quickly, very accurately, and you were able to know exactly what the data was showing. Medium judgment, your brain is all right at color and patterns. Color is classically used by heat maps. Really difficult to find a black and white icon for heat map. So you know what I mean by heat map, like or a density plot is another one sort of uses color intensity. And patterns are typically scatter graphs where you're playing out groups. So those are okay. Really bad, slow, inaccurate judgment. You're not good at angle, area, and text. Pie charts. Almost never use a pie chart. There are very few situations where it's a good idea to use a pie chart because they are really difficult to interpret. Using area in a quantitative manner is not a good idea generally. And relying on text, for example, requiring a person reading your graph to actually read what the plot labels say with numeric data, or of course using a table or anything like that, is difficult and slow and inaccurate. People will be bad at figuring out what you're trying to say. Let's look at some examples. There's an easy one to pick on, the pie chart here. Who can tell me which is bigger, 1 or 6?
The same.
6.
Same.
They're not the same. You've got to pick one.
Most people are going for 1.
6.
How about now?
Now everybody's gone for 1.
There you go. All right. Hopefully that's illustrative there of what I'm talking about. Right? Angles are really, really difficult to be accurately quantify. Also here, we've got some other problems. The legends is disassociated from the plot. So that slowed things down for you, right? I said 1 and 6, you had to first go and read the numbers in the legends, figure out which colors they were, and then go back to the plot and go backwards and forwards like this, trying to figure out which one is which. Whereas on the graph on the right, 1 and 6 are just there. And also the pie chart here, in this case, required you to basically use the index of the color to figure that out. Again, on the bar chart on the left, you don't need any color. The numbers are next to the data. Of course, you could use a floating label on the pie chart to get around some of this stuff, but that was a bad graph. That was a bad graph if I'm trying to make the points that 1 and 6 are different anyway. Anyone tell me what's wrong with this plot?
What's wrong with this plot?
You see this kind of graph in infographics on adverts and things like that all the time, and it really annoys me.
Can I summarize it? So what was your point?
There's no x-axis.
Right, first point is there's no axis. So people saying they don't know what the x-axis is.
Yeah, valid. That wasn't the point I was trying to make, but I agree.
We've got a point that is ugly as well.
It's deal with area, and it is difficult to say if it's twice or 1.5.
Jan says it's dealing with areas, so it's very difficult to tell whether it's the height of the objects or the area of the.
Spot on. Give that man a cookie.
Jan gets the
Yeah. So the numeric data is being encoded with height, right? The y-axis has got the number, but your brain doesn't care about that. Your brain jumps to area. And the difference in area here is much bigger than the difference in length. Never use a graph which conflates 2 different types of measurement, right? If you're using length, use length and keep the implied. Okay, obviously bars, the area changes, but the width of the categories here is changing, and that's a bad thing. Oh, this is out of Keynote. I use Keynote to make my slides, and I love this. All right, I'm not gonna squeeze this one out of you. Hopefully obvious. The 3D was completely arbitrary and made it much more difficult to actually compare the numbers because everything was tilted at an angle. You can't line up the lines properly, or you have to do that in your head, which requires effort. And the color and the texture is just completely overboard and takes away. So although the plot on the right is much more boring, again, if you're actually trying to make a point about what the numbers and about the data in the plot number 2 on the right there is far more effective. Okay. Aspect ratio, another one of this. I love this talk because I just get to like basically go on about all the things that annoy me. It's like very cathartic. Anyone tell me what aspect ratio means very quickly?
Yeah, everyone's saying the ratio width to height.
Yeah. Basically whether something is squished or not. Right? When you drag that little box in the corner to resize something, do you hold shift and it stays equal aspect ratio, or does it wiggle around as you drag it? Always hold shift. Aspect ratio is really important for 4 different types of things. Images here, you can see hopefully very obviously that the image has been squashed. Aspect ratio is important for any image, photo or microscopy image or whatever. Images should always have a fixed aspect ratio. Text should never be squashed. basically anything with a circle. And graphs where the axes have comparable units, where you're comparing a number against a number on the two different axes. Is this okay? I've got a series of these. One thumbs up or thumbs down.
Is it okay? Put your thumb up if you think it's okay. Put your thumb down if you think it's
Which
not.
one should you?
That transformation, is that an okay transformation to make? So we got 2 thumbs up, thumbs up.
Yeah.
Put your thumb down like this so you can see.
I need you to do this if you think it's bad, maybe.
Arms up if it's bad.
Right, this one's okay, right? The text has not been squashed. And there's nothing wrong with squashing the axes, bringing them closer together here, because the aspect ratio for this graph is not important. You got away with this one. How about this? Can anyone tell me what I shouldn't have squashed? Why is that? Why am I not allowed to do this? Which of those categories that are in here?
There's the numbers.
Yeah, so there's text, which got squashed.
Everything.
We've got somebody saying the area has changed.
Yeah, relative area has changed and it's their circles. What about this one? Oh.
The area is maintained in that one.
So we had a pause after you said circles, so we lost you a little bit with the Swift.
Oh, I just said, what about this one?
We had a question from Ed. He said, but aren't the areas still, the relative areas still maintained even when you squash it like that?
In the last slide, in this one.
Yeah.
I don't know, maybe. I need to go away and think about that. the main thing I was thinking of is it circles and it looks bad. Whether it's actually invalid now. When someone said areas changed, I was like, yeah, they probably have, but actually you're right, maybe the relative areas are the same. I don't know. But yeah. This one. Hand up if you think it's not allowed. This one's okay.
I think it's okay, yeah.
Yeah, this one's okay. It was basically the same as the first plot. These axes are not linked, so we are okay to change these around because it doesn't affect the interpretation. Oh, no glitch. You lose me a second.
Yeah, we're okay. I think we're okay.
Yeah, okay.
We got the catch up.
Yeah. Last one. Hand up if you think it's not allowed. I think I said. Come on, internet.
No.
There's a lot of no's here.
Yeah. You've got to actually read what the axes say to make that decision, but both sample alpha and beta here are counts, so that the values are going 0 to 14 on both axes. These axes are directly comparable, and so we should maintain that 1-to-1 aspect ratio. Yep, makes sense?
Yes.
In summary, keep your plots minimalistic, big and clear. Don't use your Microsoft Excel defaults. And if in doubt, can you draw your graph from memory? Or can you show it to someone else and get them to draw it from memory? A good plot should be possible. And then very quickly, using plots in presentations, which is a bit of sort of a tangent almost, is a good idea, especially if you've got a plot where you do have lots of data in there, you've got lots of things, and you can't simplify it anymore. Do think about sort of layering that plot and talking through things stepwise, because then that helps you lead your audience through what you're showing. And don't just stick it up on the graph and expect everyone to understand it like that, because it takes a long time. So I'm going to close my window 1 second. Hang on. Right. Cover. Color can be used to highlight specific data in a typical plot, group categories of data, and encode quantitative data. Those are the three main ways that you typically use color in a plot. The more selective you are with color, the better. Most of my examples are black and white, which is kind of boring, but I'm trying to make a point by doing that, which is that I try to only use color when I need to use color. The graph on the left is very colorful, but that actually is detracting from your ability to read it, because the colors of the bars are arbitrary. So it's better just to keep it simple and be selective. When you're using quantitative data or you're using a color scale, there's three different types of scales you can use. Sequential, which is quantitative minimum to maximum. Divergent, which is moving away from the center point. And categorical, which is what it sounds like for categories. That's a bit out of order, that slide. When you're thinking about a color scale and picking a color scale, or especially if you're coming up with your own color scale, something to bear in mind is that we are not, as humans, equally sensitive to different colors, right? This is a rainbow palette, looks pretty good, right? But if I move those onto where the actual kind of wavelength of light comes from, that you're basically, what I'm trying to say here is your ability to pick up on different colors across the spectrum is not at all even. Your eyes are not a spectrophotometer. You do not treat different colors with equal levels of intensity and sensitivity. And one of the ways to think about this is to think about the luminescence. So there's different ways to represent colors. You have RGB, red, blue, green. You have CMYK for printing, cyan, magenta, yellow, blue. One of the ones that I'm talking about here is lab, luminescence. Oh, what does A and B stand for? I can't remember now. But you also have HSL, which is hue, saturation, luminescence. So luminescence is basically the brightness of a color. Now, jet is, how many people using MATLAB? Or Matplotlib, yeah. Jet, you might look familiar to you, right? I think it's one of the default color schemes in those tools, and it's famously quite bad. If you look at the luminescence plotted underneath it, you've got it's not linear. The luminescence is not linear. AFM hot is another default. The luminescence is linear, but basically sort of is compressed into the middle, right? Anything on the right-hand side over here just blends into one chunk, and the same in the darks here. So your data range is not linear across the whole way. This is another one called yellow, orange, red, and this is a better example, and you can see the luminescence is both smooth and pretty well extended for the entire range of the color scale. So there are definitely good and bad color scales to be using to encode quantitative data. Coming back to the different types of color scales, we've got categorical on the left and sequential. Really important to think about what your plot is showing and which one of these types of color scales you need. This is another bugbear of mine. It drives me crazy when I see plots like this. This is, well, can anyone tell me what kind of color scale has been used here?
People are saying sequential, is that? Sequential.
Yeah. This is a sequential color scale. It should have been categorical. The reason why, can anyone tell me what that is? Which class it is from a legend?
Pickup.
People are saying pickup.
Yeah, you had to think about it, right? Yeah. So this, if this is categorical data because we've got the categories and the legend, and we're using the color to associate those, but it's very difficult to actually pull these apart. And if this was printed badly or if it was small, it would be nigh on impossible. So use categorical data where there's categorical color scales where there's a big change between each color here. It would be much more appropriate. Final note on colors and color scales is to remember that about color blindness when you're deciding on your color scale. Color blindness is one of those things that, well, I guess if you're not colorblind, is surprisingly common. It's especially common in Northern European men, and unfortunately, in the scientific community in Northern Europe, there's probably quite a high chance that your paper might be reviewed by Northern European men. So if you have 3 reviewers, there's almost a third chance that your paper will be read by someone who's colorblind. Right, so that's non-negligible number of people who see the world through this. So just bear in mind that some color schemes are bad for people who are colorblind. You just need to be aware of it and remember not to use them. This is a heat map. This is more from my domain, but I don't know if you guys use these kind of plots as well. Classically used is red-green color map, color scale and heat maps. Now, if you have protanopia, which is the most common form of color blindness, what you see is this. Is there anyone in the audience who's colorblind?
Me? Well, I'm not fully, but I'm partly colorblind, partly red-green.
Do you agree? Do these two look the same to you?
I mean, I can tell the different colors, but I'm getting roughly the same amount of information out of both plots.
Yeah.
That's what you mean.
Whereas the color intensity, can you see my cursor? The color intensity here in the top middle is roughly equivalent. But obviously on the protanopia view here, they're wildly different. Does this look better?
Yeah.
Yes.
So all I've done here is I've switched red for magenta, which introduces a component of blue color. And suddenly now anyone who's colorblind can differentiate this color scale. Very simple change, looks basically the same. No one will really notice, apart from all the people who can suddenly read your plot. There are lots of online tools for previewing graphics through filters which apply color blindness, which is what I've done here. I did this in Photoshop, but if you Google color blinds online tool, you can sort of dump your graphics in there and it will show you and you can see very quickly whether things need to be changed.
A quick comment on that, Phil.
Yeah.
The thing that really gets me is when I'm in talks and there's, say, a plot with like 10 lines on, and they've used a categorical color scheme.
Yeah.
In amongst, there's kind of colors which are mixed to reddy, greeny, and particularly if the lines cross each other, I find it's really difficult to say. And then they say, well, this line's like this sample's doing this,
yeah.
And if there's not some other way of telegraphing, like they've used dotted lines or they put symbols, or the order of the colors matches the order of the key, so I can say, okay, they're talking about the sixth one.
Yeah.
But that's when it really gets me most in talks, where I just can't follow sometimes which line people are talking about.
So best case, they're making your life difficult by making you think really hard to figure it out, and worst case, you just misinterpret or don't understand.
Sometimes I just can't. It doesn't matter how much I think about it. I just can't see which of those two lines that they say or the.
If I bring you back to this slide, I was saying before that red, yellow, and green traffic lights are a classic way to say good and bad, right? So red and green is a really common color pair to use in a graph, right? Red, good, green, bad. But you probably shouldn't use it, or at least you shouldn't rely on it, because that's also the most common pair to be difficult to differentiate. Final note, almost never try and decide your own color palettes, because there's tons of theory behind it, and lots of nice people have done it for you already. The classic one that's been around forever is built into an R package, but you can use the colors anywhere, called Color Brewer. And these are the kind of standard color schemes that come with that, which you can use. So you've got categorical, sequential, divergent. If you don't like these for whatever reason, you Google it, you'll find many more. And I was trying to find a link. I saw a link on Twitter just a few days ago where someone came out with some new color schemes, and they have these really nice plots underneath each one showing the relative luminescence and stuff like this. And it was really nice visualization of the principles I'm trying to, but I couldn't find it for the talk. But yeah, use Color Brewer. Right, basically done. I just finally wanted to highlight some of the tools that I use. What did I use to make this presentation, basically, and what the browser tabs that I have open. Basically, should be 5 URLs that you have bookmarked in your browser. so that you just can refer to them whenever you're doing this kind of stuff. Fonts, I mentioned use Google Fonts. This is what the website looks like. It's entirely free to use any font on Google Fonts or open under an open license. When you enter the Google Fonts website, they've got a lot of fonts, so it could be a bit overwhelming. What I typically do when I load it up, use this box up on the top left to pick specifically sans serif fonts, because that's usually always what I want. And then I sort by, I think it defaults into sort by trending. I usually sort by most popular. Like, if in doubt, don't try and remember the names of specific fonts. Chris, you have asked me multiple times, what's the name of a good font? And I nearly always say, don't ask me, just go in Google Fonts and just pick one from the top of the list. You can't go too far wrong. It's much easier in trying to remember. And then usually, if you're like me, you'll find one which is your favorite and you sort of tend to use it for everything. Fonts.google.com. I'll share the slides. Color palette. I mentioned our color brewer. If you're just designing something and not doing data visualization, you just want a nice color palette. There's a nice website called Coolers, which just it's just a whole website dedicated to building and sharing color palettes. And there's lots of ones where these are the most popular color palettes, and you can just pick them and you've got 5 colors and you just run with it. That easy. Icons, right? This talk was riddled with icons. I am absolute sucker for using icons in all my talks, and my recommendation here has actually changed. I used to recommend a website called Flat Icon, which is also good, but these days, but you have to attribute your usage of those icons, and they try and get you to buy ones by clicking on the wrong links and stuff. So I've gone off that a bit recently. Nowadays, I mostly use this website called Iconify, which is mostly actually for using icons on website design. But basically, it's a big collection of all packs of icons, which are all open license. And you can just search and then get an SVG, which you can download and drop into PowerPoint or Illustrator or Inkscape. And there are, I don't know how many thousands there are, but there are very, very many icons to choose from. Photos. This talk, I haven't used photos very much. It depends what mood I'm in. Some talks I give, I have a lot of photos and images just to make it look nice. And again, of course, you can sort of have an image kind of gives you an association. This talk was very visual, so there's lots of visual information I was trying to tell you on every slide, so it wasn't really appropriate. If you have especially a short talk or something that's very conceptual, then imagery might be more appropriate. You basically, if you don't have a lot to show on your slides, photos can make it look good while still kind of giving you some help. Unsplash is an amazing website where, again, there's loads and loads of royalty-free images which you can use for anything. You don't need to worry about copyright too much. It does say, please say who took the photo and stuff, but you can use it for whatever. And you just type in a search term at the top and you have loads of really, really wonderful photos to use. And last one, Inkscape. So I personally use Adobe Illustrator to do editing vector graphics. Vector graphics being ones where you can actually like drag the lines around and move them, rather than something like Photoshop, which is for bitmap images. But not everyone has access to Illustrator. It's not a cheap piece of software, and Inkscape is free and does basically the same stuff. And it's a really nice tool. I've given training on how to use Inkscape before. In fact, when I first developed this course, part 2 of it was all about using Inkscape. And what I didn't actually say explicitly, but is really important, is don't be afraid of using editor tools like this, right? If you generate a plot in R or MATLAB or whatever, save it as a vector image, as in SVG, not like a PNG file or a JPEG. Save it as an SVG and load it up in Inkscape, and then you can mess with colors, you can change the fonts, you can change font sizes. Very often you need to make font sizes on the axes bigger, things like that. Fix alignments, do all these little tweaks in Inkscape. As long as you don't mess with the, the data, there's absolutely no problem with that at all. And there's usually the final polishing step, which makes the difference between a good and a great visualization, especially in papers. Right. I'm about out of time. I'm going to leave. We've got a few minutes to leave for questions at the end, but in summary, if you forget everything else I've talked about, this is the slide that I want you to remember. Visual aids are important, worth spending time on, worth your attention and your thought. They are easy, especially if you practice this stuff and get into the habit of using nice fonts, of using good colors, of following these good practices. Then visual design is easy. And the reason for doing visual design and visual aids is that they make it much easier for you to explain stuff. They make your talks and your presentations and your papers much more memorable and interesting. And you will effectively communicate your science in a better way. Any questions? Oh, I'm frozen.
So you froze after you effectively communicate.
I just asked if there are any questions.
On the message.
I'm done. So we've got,
Right.
I think on the schedule, we've got 5 minutes left, if I remember correctly. So happy to, I was going to do a quiz and stuff at the end, but I was worried about running out of time. Ooh.
Well, we can take a bit more time, I think, if we need to, but should we just do some questions quickly? Is it up?
Yeah.
I'm very interested in infographics, images, usually they are very nice. But when I want to imply some into science slides, I find it very complicated because they are very designed for communication, for getting image. When you want to go to science, you have to build them yourself. So my question is double. First, what kind of tools can I use to build such image, the easiest one? And second, what are the ingredients I should keep in mind to build the small icon that will be used for me to really get the message when it's a science?
I lost the last bit, but I'll try and recap. So the questions about infographics. Firstly, infographics are brilliant, but bear in mind the formats that you're displaying them in. Infographics were classically used for printed material, especially when you have quite a lot of space, or web pages as well, where you have quite a lot of space. On PowerPoint slides, infographics can be too dense. So just bear that in mind, or think about maybe breaking things into panels so you can split them across PowerPoint slides is just the first thing I'd like to highlight. You asked about what tools to use to build them. I would use Inkscape. So for when there's basically, when it comes to image editing, there's these two different types, bitmap and vector. So bitmap is Photoshop, or the free equivalent is a tool called GIMP. And that's for editing photos and things like that. But especially if you are drawing things or synthesizing a new image, you should basically always be working with vector graphics, where you can drag the handles around and move the lines around and things. And Inkscape is free and a really good tool. Like everything, there's a bit of a learning curve, but you do a tutorial or two, start using it a little bit and playing with it, and you can get you can build. If you go to the Inkscape website, they've got, like, featured gallery, and you'll find people doing, professional designers using it to build all kinds of nice things, like this image. So that's what I would use to build an infographic and have done. And then, of course, you can bring in elements. If you have plots or graphs or things, you can bring them in. Very often, if you're doing an infographic, your focus is on message and much less on data. So if you do have any graphs or anything, you would typically strip them down a lot more than you would do in other situations. So you'd remove that data simplicity is much more important. I think you asked about icons. I would use Iconify. It's kind of my go-to place to pull out icons, or there's that other website I mentioned, which is called Flat Icon. So then you've got your kind of points, you've got your data, maybe you've got some icons. Think about very short text typically, so think about your kind of headings. Think about a gross layout of roughly how your infographic is going to look. And then the final element for an infographic is typically kind of background imagery. So think about what colors, if you want to have like a big moving like arrow, or any other kind of supporting imagery. Iconify has some of that. Flat Icon is maybe better for that sort of more rich background imagery, you know, you want, I don't know, some grass or a waterfall or something like that. Then flat icon is a good place to go for that kind of stuff. Does that help?
Yeah. Are there some rules we could learn, like books or handbook or something, to learn about that, to better communicate in science?
Many.
So can you utilize one, because I never found one?
Yeah. Not off the top of my head, sorry. I don't trust myself to give you a single. I need to go away and think about it. I haven't read. So honestly, the way I personally tend to learn is learn by doing and reading web tutorials. I don't spend very much time reading books, so I'm not the best person to ask for that. But if you go to, I can tell you what, one book I love. I will just share my web browser for a second. I'll try and find it for you. Is Information is Beautiful book by a guy called has this come up already or something? There we go. David McCandless, is he called?
On the table, Phil.
Yes, yeah. Oh, I love that book. Knowledge, yeah. There's a few different iterations of that. Yeah, exactly, yeah. He's got about 3 or 4 of these books now, and they are fantastic coffee table books. And I think really it's not designed as a textbook to teach you, but if you spend enough time leafing through the pictures and really thinking about how he's done those infographics, how he's done those data visualizations, what's different between those and the ones you might normally see, that is a great training material. And yeah, I really like those books.
Thank you very much.
Problem.
Did you ever use bionic reading, the one you share with? You know, it's a website that can change the text, changing only the first letter of the word in both. You share it, if you remember. And I don't know if you know it, Phil, and if you already tried inside PowerPoint.
Did you follow that? You know, bionic reading. So it's the thing that for ADHD that puts the start of each word in bold. Right. Whether you ever tried that in presentations.
No, so I'm aware of it. It's gone around a bit just recently, I think, as well. And we were talking about there's previous iterations of similar things. I remember there was one that used a red line to censor the word and again flashed up the image of the words. You could use that. If you feel the need to use that, I would argue you have too much text on your slide. But
I have too much text for a reason. I don't know which one, but let's say I need to put this text for a reason. Maybe it could be effective to have if I really can't pronounce text.
Yeah, so the questions may be more, if for some reason you absolutely have to have a big block of text on the slide, have you got any tricks to make it a little bit more digestible?
Yes. Use font weights, which is basically what you're suggesting, right? The slight difference is what you're suggesting is this using variable font weights in every single word, right? To emphasize parts of a word to make the text easier to read. What I would say is for a visual aid, maybe it's better to bring out chunks of words using font weights. So the difference is then I'm not trying to help you read the entire text better or faster. I'm trying to let you skip between the important bits of text so that you don't have to read as much text. There's no one answer for this. The answer really is it depends.
Any other questions?
I was wondering if he has any recommendation besides PowerPoint. If there is another important tool, another variation or something, because sometimes I have trouble if I'm working in my personal computer and I have to do a presentation and I have to transmit the PowerPoint archive into my IMN computer. Things are changed and I don't know.
Yeah.
They moved. Sometimes some icons are not available depending on the system.
Yeah, really good point.
Using Google Drive or something like that.
Yeah, So there are the three main tools. This talk I'm giving to you right now, I use Apple's mostly, so I'm using a MacBook, and I use the default software that comes with Apple, which is called Keynote. It's a bit like I was going to say Marmite, but you guys are not British, so you might not get the reference. Basically, people would tend to either love or hate Keynote, and often it depends. Keynote versus PowerPoint depends on which you're most familiar with and which you're faster with. I personally love Keynote. I think it's fantastic and much better to PowerPoint, but PowerPoint's got better in the last few years. The third one is Google Slides. So if you're using either Keynote or PowerPoint, especially, as you say, you should always try and present on your own computer if that's an option. If it's not, I would recommend try not to use any animations and export your slides as a PDF, at the very least as a backup. Basically, pretty much any computer can present a PDF as slides, and you can skip through them. And PDFs embed fonts and embed images, so it should always look exactly as you expect. So when I go somewhere to give a talk, what I nearly always do is I have the slide deck I want to use, which is Keynote or PowerPoint or whatever with all the animations. And then I also export a PDF as a backup in case when I load it up, it looks wrong. But if in doubt, especially if you're not particularly fussed about using animations, which you don't need, use a PDF. Google Slides is a good option because Google Slides doesn't rely on any software on your computer. It's completely in browser. So that should also be much more transferable across different systems, but it's not perfect. And there's some stuff you can't do in Slides. For an example would be, have I used it anywhere here? Come on. So both PowerPoint and Keynote have a feature which is called, in Keynote it's called Magic Move. I can't remember what it's called in PowerPoint now, but these are two different slides here where I go from there to there. And that's an animation which I've used, and it's a transition animation between the two different, between the two different slides, and it just moves the objects from one slide to the other. I use that, if I'm using animations heavily, I use that a lot because it's way easier. And that's a feature, for example, that Google Slides doesn't have. But yeah, if in doubt, use a PDF.
Okay, thank you.
I have two questions. The first one, what is your opinion about animation? Do you think that they can catch the attention of the public, or sometimes if it's too much animations, they can distract the public? And my second question here is, for example, when you're giving a conference, you always try to avoid to use a lot of words. But when you are teaching or giving a class, like I have seen, like usually the professors, they write a lot, but sometimes I don't feel that this is good for the student.
Yeah.
So what's your opinion there?
Animations are something you should use carefully, right? Where is it? I've got an example up here of a bad animation. Here we go. I put this in for a bit of fun, right? That is a bad animation with the water, right? And animations should be used very sparingly. Most of my animations in this talk are very fast and subtle, right? This is the one I currently use the most in Keynote. It's called Fade and Move. And I always try and keep an animation to maximum 1 second for anything. I use 1 second if it's over Zoom. If it's in person, I typically use half a second. But over Zoom, half a second sometimes is too quick, so it doesn't show at all. So animations should be subtle and used sparingly. And the other thing is, if you have you shouldn't have too many on a page. So this slide, for example, I've 1, 2, 3 animations, right? I didn't go 4, 5, 6, 7 animations on all those bits of text on the bottom, because that would sort of be too much. So you should think about how many animations, how many different points you're trying to make. Again, it's not about the animation, it's about what's the argument you're trying to make, what's the point you're trying to get across. Here I had three points, so I have 3 animations. So don't use them very much, keep them fast and simple, and if in doubt, don't use any at all, I would say. Second question. Oh, I've forgotten. Just remind me what it was.
It's amount of text, because especially when you are in a
Yeah.
congress, you usually avoid to put a lot of text. But in a class, the professor, they usually write a lot. Well, some of them, not all.
Yeah. This is a bit of a personal preference thing. What I tend to find is that people giving talks, the more nervous a speaker is, the more text they put on the slide. Also, the more that a professor is in a rush, the more text they put on the slide. And there's the second reason for doing it is if the person presenting knows that they're going to print out all the slides and give them to the students and be used as basically reference material without them stood in front of the slides, they might put the text on. So whether it's standalone and also how nervous you are. This slide deck, so Chris mentioned that I did this talk back in however many years ago. I was going through and I cut out loads of text, right? I was like, slides like this, I had as three bullet point texts, which was fine. But I went through and I was like, this is just, I don't need all this text, right? I'm talking to you. It's much easier to like listen to a person talking and engage with a person. And when you're watching a talk, the natural thing that people want to do is watch the person's face and mouth and body language. And so that's more important than text on your slides. So the less text you have on the slide, basically the less information you have on the slide, the better, I would argue, because then it's going to be easier for you to pay attention to me and easier to get the point I'm trying to make, rather than you trying to do 2 things at once, where you're trying to read all that text before they move on to the next slide, and you've just not listened to what they've said. So I always go less text, the better. If you are presenting and you need to remember the details, use presenter notes, right? I haven't used them on this, but at the moment I'm screen sharing in the middle of the screen. On my left-hand side, I've got all the slides which are coming up in order, which is how I'm flicking between them. And underneath each one, I've got the slide notes. Now, I could have written those bullet points there, so I remember what I'm going to talk about. So if you need that written material as a crutch for when you're presenting, use slide notes, which everyone else can't see, but you can see. If you're using another computer, print them out just in case the setup means that you can't read them. So if you have a printout as well, you can at least use that. And also if you're teaching, the presenter notes are good because you can print out from PowerPoint and Keynote, at least, you can print out the slides with the slide notes next to them. So then the students will still get that written reference material, so it will stand alone by itself, but you are not forced to put all that text onto the slides.
So, this is Ed Goldman here. I've been, when we put the sign on the face of the person who's making the presentation, I've been to several conferences where the person is quite happy to have, when you're giving a presentation, you're lit.
Sorry, I lost you for the middle part of the question. The connection dropped. Can you just repeat it? You've been to conferences where you've seen people talk. And
they stand in the dark because no light is provided on their face. But do you think it's important that the person giving the talk is visible because they are lit?
Yeah, I do. It comes back to the same point where we're really right. I mean, we're animals, and we have had millions of years of devoting our evolution to be really, really good at synthesizing this visual information of body language, of understanding speech, not just through the audio, but through watching people's face, right? It's much more difficult to understand what I'm saying if I hold my hand in front of my face. It's much harder for you to understand, especially if English isn't your first language, or if I have a strong accent, or I'm talking quietly. Being able to see a person as they speak is really important and massively helps comprehension. And also attention. It's not a coincidence when you browse the web that lots of adverts that pop up have a picture of a person. Because it's like using red and having people's faces. They're really attention grabbing. We're hardwired to pay attention and understand people's faces more than slides. The visual aid is a secondary thing to your talk. It's not the primary thing. And that's kind of how I view it. So yes, people should definitely be illuminated. Further than that, if it's a big lecture theatre, there should be a camera pointing at them, and their face should be shown alongside the slides if possible. You go to any big conferences or any big trade shows or anything where this is done on a very professional level, you will not see a single talk that doesn't have a video capture image of the person talking. You take it to the extreme, of course, TED Talks are famous for this. You have the person stood on the little red carpet at the front. And yes, they may have some slides, but really they are in the background.
Thank you.
Any other questions? I think maybe later in the coffee break I'll chat with you, but I don't know whether people know things like the difference between vector graphics and bitmap graphics and some of the other technical things that Phil mentioned, but if you're not clear on those, come grab me in the coffee and we'll talk through what those things are.
Yeah, that was like I say, that was sort of part 2 of the original version of this course, bioinformatics. I see if it's just so you know what the web page looks like. This is my old group from many years ago now. Training, visual. Is it? This is all biology, but the data visualization stuff should be the same. Oh, I can't find it now.
I have another question.
No, that's like it's possible to have just next.
He's recorded, so he's going to put it on YouTube. So then, if you want to watch again,
yeah, I'll share a PDF of the slides as well.
Okay. Thank you.
Yes, I forgot something. You were talking about Inkscape. Do you have a website like you can recommend to take some tutorials about Inkscape?
Yes. A bit random. Firstly, there are many, and you should probably not listen to me about this recommendation. But so I mentioned at the start that I work with building community in bioinformatics. The main community I've created is this one called NF Core. And anyone doing data analysis should come and check us out, because I want you guys to build physics and chemistry pipelines, data analysis pipelines with us. That would be really fun. But anyway, we're a big community, and we have weekly talks, which we call bite-sized talks. And some of them are about the data analysis pipelines themselves, but some of them are about sort of basically we use as training. And James, who's in the core team, last July, he gave a talk about Inkscape. He was specifically talking about making these graphics, which we use in the community, but it starts off with a general introduction to using Inkscape. That was a really nice talk. So that's the first one that jumps to mind when people ask me this in my usual day job. I point them to this. It might be a little bit irrelevant, but at least it's sort of something. I can vouch for the talk. Otherwise, I mean, if you go to Inkscape, then they have quite a lot of information on their website. If you Google it, you'll find loads of things. And also that link I was looking for a second ago on my old group, the Babe in Bioinformatics, that's like, I think it was, when I originally wrote it, it was either 2 days or 3 days. And like day 2 is using Inkscape. and it was a tutorial taking you through, like, you know, you work together with the presenter. We don't have time for that today, but that was really good. I was trying to find it a second ago, but when I'm finished, I will dig out the link and I'll send that through along with the slides.
Thanks, Phil. Right. I think we're done.
Thank you.
Thank you very much.
Not at all. Thank you for your attention. And yeah, feel free to drop any questions you have afterwards in an email or via Chris or whatever. Happy to continue the conversation.
Thank you. No, thank you very much, Phil.